Hello students, this is Mr. Amarjyoti Nath coming with a short video of a numerical problem of physics. In fact, today's problem is that the main problem of that one 24th of February. Okay, the problem is this: if two identical capacitors, once connected in series, the C equivalent is C1, and once connected in parallel, then C equivalent is C2, then find the ratio C1 to C2. Well, that is the question. So I hope you are going to try it before I solve. Okay, then you write that actual answer in the comment box. Well, so let me solve it. In the first case, first of all, they are saying that we have two identical capacitors. Well, and here we can write first one is in series. Okay, if it is of capacitance C, then another also will be of capacitance C only. Okay, as they are identical, so now they are in series. Okay, so in the first case, so what is the capacitance between say point A and B? Well, so it will be equal to C1 according to the question. Okay, C1 is we understand that when two capacitors are in series, they are actually net capacitance. Okay, to calculate the net capacitance, what we do, we add them reciprocally, na? So 1 by C plus 1 by C. So it means from that we can easily calculate that C1 equal to C by 2. Again, in the second case, the two capacitors are in parallel. Okay, they are identical capacitors, they are in parallel. Well, so now what is the capacitance between A and B? Okay, this is said to be C2. Okay, and we understand that when two capacitors are in parallel, their net capacitance always just the algebraic sum of them. Okay, nothing else. So C plus C, it is nothing but 2C. Well, so what we need to do, we need to find the ratio of C1 to C2. Okay, therefore C1 to C2, C1 is just a half. Okay, and that is 2. Okay, that is half C, and this is 2C. C got cancelled only, so it is 1:4. Okay, 1 by 4 you can say. So it means C1 to C2 is what? 1/4. So that fourth answer is option is correct. Okay, hope you will share the video with your friends. Okay, so that other students also get to know about this. Okay, thank you.